All right, so in this section, 4.5, we're going to talk about all the things we've been doing in sections 1 through 4 for function analysis, i.e. increasing, decreasing, concave up, concave down. And those are going to start to mean things. And so now what we're going to do is we are going to talk about this word right here, this optimization. And optimization is just what it says. We want to optimize something. We want to optimize something, okay? So what that means is we want to make it as big as we can or as small as we can, okay? So what we need to do is have some finite intervals, which means we're going to have some limiting factor, okay? A limiting factor. So finite and closed. And these are real world problems based on things that have to happen in the real world, okay? So let's do example 1. It says a garden is to be laid out in a rectangular area and protected by some chicken wire. What is the largest possible area of the garden if only 100 running feet of wire, that's fencing, is available to make this fence? Okay, so there's a graph over here. We're going to talk about that shortly. But in order to come up with the graph, we need to have some information. So if I can scroll back down here, you can see there that's square feet area versus our x feet in length, okay? And if I know nothing else, I have some sort of graph here. It's telling me that I have some limiting factor. So clearly, if I get numbers beyond 0 or 50, I've got some issues. But they're also telling me, based on this curve, that I know where my maximum should occur, okay? That would be the maximum area. If I look at the picture, I can also see that it looks like it's a parabolic in nature for sure. And they're telling me that they know that the maximum is going to occur at 25. They're pointing that out to me. So that's a hint, hint, hint. If I get a number starkly different, significantly different, I'm going to want to take a look at my work. Okay, so I'm looking for maximum area. And here's where I get this largest possible area. So in order to find a maximum, how did I find a maximum or minimum in sections 1 through 3? How did I find it? Say it, say it. I took the derivative, correct? Well, I have to take the derivative with respect to something, so I'm going to need some other letter, okay? Well, the area of a rectangle is going to tell me I'm looking at this, okay? So length times width. And I'm using a funky pen, so sorry. Okay, so length times width. And, okay, and then I'm told here I only have 100 running feet of wire to make the fence. So if I draw a little picture to myself, and I say I'm looking for some rectangular space, okay? So I'm looking for some rectangular space. And I know that this rectangular space is rectangular, so my opposite sides are the same. And total to cover that is 100. So I can come up with another formula, because right now I don't know length or width. But I can say, well, I know that the length around something is called a perimeter. And so I have that. I also know that the maximum I can have there is that. Okay, so with that being said, I want to now take a look at, okay, well, I need to solve for a letter because I have to decide what I'm going to differentiate with respect to. So I'm going to go ahead and choose length because I don't know, I want to. So 100 minus 2w all over 2 is my length. So now I'm going to take this and I need to come over here and plug it in here. Okay, so now I'm going to have 100 minus 2w all over 2. It's okay, Miss Love. I don't mind background noise. Times w. We'll see who was listening. Bonus points. Who walked in during the lesson? Okay, so I'm going to now take the derivative of a, and now look at I only have one variable. So now I can decide that I want to take the derivative of A with respect to W. Okay? So if I do that, I want to take the derivative of this.
Audrey Anderson, please come to the front office. Audrey Anderson, please come to the front office.
And I want to simplify that. Board is awesome. Our pen's missing. Okay, so now this is my area formula in just regards to W. So I want to take the derivative of the area with respect to W. And I get 50 minus 2W. So in section 4.2 and 4.3, we said, hey, to find a max or min, we figure out where the first derivative is equal to 0. And if I solve for W, I'm going to get 25. I mean, wouldn't that be awesome if that showed up? 25. Okay, so remember the graph? The graph from up here. Look at this. Oh, good work, good work. We have that W right there. So far, so good. We're on the right page. All right, so scroll back down. And now I'm going to take a look at my sign chart. So I'm going to put my sign chart at 25. And a number to the left. Miss Collins, probably not a good choice since you can't have 0 length, right? So let's go with 1. And then let's go with 30. And so when I take a look at this, so this is my sign chart for F prime. This is F prime. So when I plug in 1, I'm going to get a positive number. And when I plug in 30, I get a negative number. This tells me that my area is increasing until I get to 25. And after 25, my area is decreasing. So my hope is my maximum area is going to occur. I don't want to put it equals. I want that it occurs. So my maximum area, is at x equals 25. Okay, so remember your formula for area, because we're not done. We haven't actually answered the question. What is the maximum area? We don't have that answer. But you just know that it occurs at x equals 25, or, my bad, W equals 25. So area was length times width. But wait, I don't know L. So now I have to go back to the perimeter equation. Plus 2W. So 2L has to be 50, so L has to also be 25. So my area maximum is at 25 squared, which is equal to 625 square feet. Now, I'm coming up here. I want to look at the graph, and I want to see that this number right here looks pretty darn close to 625. Okay, looks very, very close to 625. Here's the deal, kids. When we're doing these, we're really just doing a lot of algebra 2 and a little bit of calculus. Some of the equations might actually look like pre-calc. However, what we're really doing is solving for systems of equations, figuring out all the stuff that we do know about the real world prior to actually solving the equation. Okay, so area, perimeter, substitution, simplification, and then way down here is where we start to do the calculus. Okay, this is calculus. Everything else is pre-knowledge, okay? So pre-calculus, those 4 years, going to be very important right now. Okay, so that's an example of the basic optimization. Let's take a look at another one. In this one, we want to talk about the process first, okay? So most important, I cannot stress this enough, visual learners, this becomes absolutely crucial, okay? The second thing we want to be able to do is recall all of those formulas from those 4 previous math courses. The third thing we want to do is we want to consider the conditions stated in the problem, which means throw things out, figure out what maximum or minimum for a certain quantity is. For example, I can't have a length of 0. That's no length. Okay, so 0 is going to be an option to throw it away. And the other thing we want to consider, and we'll show you in the next problem, if something makes it not exist, if something makes something unrealistic, unviable, we need to throw that out. That becomes our limit. Step 3 is logic, okay? Step 3 and step 4 go hand in hand. Physical restrictions, right? And then if applicable, we want to talk about taking the derivative, doing a sign test, and there might be more than one value. So we need to figure out which one is going to optimize our situation, okay? So this 5-step process right here, we're going to use on every single one. Okay, we actually did this problem in pre-calc, by the way, in our pre-calculus book. So this is going to be the last example I do today, and then I'm going to give you a book assignment, okay? Section 4.5 is a 3-day process. So day 1 is going to be basic, but not super duper short. The problems are still long. Okay, oh, too far. Okay, so example 2 says we're going to take a box, and we're going to make it by cutting corners out, and the length of those sides of the corners is going to be X, okay? And then what we're going to do is we're going to fold up those edges till they're connected, and we're going to have a box. So the center picture, or figure B, shows you that when you fold up those edges, you're actually going to get the height of your box, okay? So now, at this point in time, we're going to read the problem, and then I'm going to have you pause it. So let's read it together. An open box, so we don't have a lid, is going to be made from a 16, inch by 30-inch piece of cardboard. You're going to cut squares out of equal size, hence square. No square is going to be bigger than this. So you have a square, 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 square. We're going to cut those out, and then we're going to fold up the 4 corners. What size should the squares be to make your box of largest volume? Okay, at this point, I now want you to pause, and try this on your own. Okay, so you should have come up with the volume is equal to the length times the width times the height. And if I FOIL this out, I'm going to get 480 minus 60 minus 32x plus 4x squared. And then I'm going to take all of that and I'm going to multiply it by x, and I'm going to condense. And so you have paused this, so now you're hearing me work through this problem. You should only be listening to me right now to check your work, okay? Check your work. Your work should be done. If you have not done it, pause the tape now. Okay, sorry, I'm so excited about it. 480x minus, that would be 92x, so 92x squared plus 4x cubed. Okay, now, I should note that volume is a cubic quantity, and I have a cubic, so that's excellent. And in my head, I need to be thinking about a couple of things. And so I'm going to come up here, and in my head, I realize that x has to be less than 15, because at 15, the length of that side becomes 0. Furthermore, I have another restriction. X has to be less than 8, because I have an issue. Because on this side, if x is less than 8, my side doesn't exist. If it's greater than 8, I should say. So abort, abort. If x is greater than 8, that doesn't exist. If x is not less than 15, this side doesn't exist. And a height of x, well, clearly x has to be greater than 0. Okay? Now, I should be able to now look at this picture over here and see, well, they gave me the answer, kind of. But if I did some work on my calculator, I could generate this picture based on this function. And that's all great. That's fine. But here's the bigger issue. Notice they came up with the same domain restrictions I came up with. Notice anything between 8 and 15 will not work. And the reason is this becomes more defining than the larger number. It's a smaller window, and therefore you go with the smaller window. So because I want to find my maximum volume, I'm going to go ahead and derivatize the V. So I'm going to take the derivative of this. So the derivative of V with respect to X is going to be 480 minus 92X plus 12X squared. Oh, Miss Collins, you silly girl. You did not multiply correctly. I'll help you out. 92 times 184. 184. Yes, it is. And checking my math. Okay, so now here I am. And so are they all divisible by 12? No, they're all divisible by 4. So I'm going to go ahead and make this look a little prettier. I'm going to take out a 4. And I'm going to write it in descending order. So 3x squared minus 66 and plus 120. I believe that's correct. And now I want to set that equal to 0. And by doing that, I can get rid of that. And so now I'm hoping this factors. Oh, wait, I can divide out. Miss Collins. I can divide out a 3 now. Now I can take out a 3. I'm so silly. X squared minus 22x. I'm glad you guys are all watching my thinking process, but you should be done by now. It's just going to take me a lot longer to get to where you guys are. 40. It's the end of the day. I had a long day. Miss Harris asked me a lot of questions today. And Maxim, let's not even get started on Maxim. Okay, 10 and 4, 8 and 5, 20 and 2. Okay, x minus 20, x minus 2. And so I come up with 2 places at 20 and 2, and that's clearly incorrect because they're telling me it should be around 3. So now I need to check my math and make sure I didn't screw something up. So I'm going to pause for just a second so I can check my math. I might have to pull a Mr. Clinton aboard. Hold on, I'm pausing to check my work. Okay, I found my error. I knew it didn't match my notes, and so now here I am. Okay, so here's my error. Right here, you're going to see I clearly do not know how to factor. And so what I want to make sure you understand is, yeah, you can make errors pretty easily here. So I'm going to go ahead and fix my error because it should have been a 46 here. So no, I can't take out a 3. And that makes me feel much better now that it matches my scratch paper. Okay, so this should actually be a 46. So easy to make a mistake. Please don't do it. Try not to if at all costs. Okay, so now 3x and x. And now multiples of 120. So I'm going to go ahead and move that. And so multiples of 120 include 60 and 2. 120 and 1 is out. 30 and 4. 40 and 3. 30 and 4. 12 and 30. No, that's going to give me 42. Okay, so let's see. What about 5? 5 and 25? 4. 15 and 24 is, nope, so close and yet so far. Oh, what about 4? No. What about 2? Okay, what else? 6? 6 and 20. And what else? I need to get my pink sheet. I don't know why I'm trying to do this by hand. Where's my cheat sheet? Oh. Okay, so if you list out the factors of, I did it, I found it. List out the factors of 120, which I started doing, and then it turns out that there's, oh, hello, there's another one, and it is, where am I? God, I should have paused this. I'm such a silly girl. Oh, Did I? I did. Okay, my bad. So what's the other one? Oh, 10 and 12. Hello. 10 and 12. And there's your answer. I knew I had it. So minus 12 minus 10. So negative 36, negative 46. All right. I am so slow sometimes. I hope you did it faster than I did. So x is either 10/3 or 12. And when I come back up and look at what my domain restrictions were early, 12 is outside. So guess what? 12 is out. In fact, I want you to make sure you note 12 is out. 12 is out. So can't be 12 because of the domain restriction. So x has to be 10/3. And that makes me really happy because when I come back up and look at my graph, close, 3 1/3. Okay, so now I want to do my sign chart because I want to make sure I do every step. So 10/3. So I'm going to go ahead and choose 1 and 5. So I'm going to look here at this derivative. And if I plug in 5, I'm going to get a negative number. And if I plug in 1, I'm going to get a positive number because a negative times a negative is positive. So my sign chart is going from increasing to decreasing, which means a max, which also means at x equals 10/3, that's when I'm going to have my Vmax. So I want to come back up to my velocity equation, my volume. I'm so excited for section 4.6 coming up. So my maximum volume was 30 minus 2 times 10/3, and 16 minus 2 times 10/3 times a height of 10/3. So 90/3 minus 20/3 and 48/3 minus 20/3 times 10/3. I'm doing this without a calculator. Hey, feel free at home on your own to do these with a calculator. You might not run into some of the math errors like I did. Again, cut me some slack. It's the end of the day. Well, I make them during the day anyway, so I guess it doesn't matter. I'm okay with that. So 700 times 28 all over 27, and really should use a calculator at this point. 56196 over 27. And that's going to be cubic feet. Let's come back to my units. Inches. Cubic inches. Okay? So that's the first two examples. Okay, the first two examples. So what I want you to do right now is stop the video, because if you keep going, there's no more video. The video will stop. But the notes are still there, so you're going to notice I've only done the first 3 pages, maybe 4 pages of the notes. I'm going to finish the video tomorrow after we've done some practice in class. So we're going to stop the video, and now you're going to go and do these problems. So this is going to be on page 283 to 284. And what you're going to do, it's actually mostly on 284. You're now going to go ahead and do numbers 3, 4, 5, and 6. I only want you to do 4 problems tonight, okay? Just 4. And what I want you to do is I want you to show me your equations, the formula. Make sure you take your derivative, and make sure you use appropriate notation, okay? Hopefully you'll actually come in with the answer. That'd be great if you could have the answer too. Happy if you have the answer, okay? That's on page 284, and you're only going to do numbers 3, 4, 5, and 6. All right. Again, bonus if you can tell me who walked in during the lesson. Peace out.